computer to work on homework. That entire f of x is getting squared, so put a bracket around f of x. Think of that as outside portion versus inside portion. – 11, 12, 16, 17. And once you have the derivative spelled out, replace every x with 9. We should be able to end up with g prime of 9 equals 6. Part B, we should be able to find the derivative first, product and a little bit of chain. F prime g plus f g prime, but within f of 3x, we gotta go through chain rule. F of u becomes f prime of u times u prime. Um, so once we're here, replace every x with 3. So we get f prime of 9 times 3, and f prime of 9 to f of 9, you can fold the table and just plug all numbers in. Okay, next up, part D. We know that the big picture is that f double prime is going to rise up to f prime after we make it go through the antiderivative process, but that 3x is in the way a little bit. We got to go through use substitution. Take care of that coefficient. So if our u value is 3x, our derivative is 3, dx equals u over 3. Everything in terms of u, we know there's a 1/3 that we can push out in front. We know antiderivative of f double prime will make it rise up to f prime. Replace the u back in terms of x. There's a 1/3 that's now part of this antiderivative, plugging my upper and lower bound. We want to make sure that there's a match with variables, right? After you find your antiderivative, either you bring your 0 to 3 in terms of u, or I think most of us prefer just bring everything back in terms of x. Then use your table to get it down to a numeric answer. Okay, page 20, part H. Everybody good? Up to part D. So we have the n of x is the integral of 0 to x squared. It should be t here. Variables should not quite match, but we get the idea. It should be f prime of t dt. Evaluate n of 3. We can just plug 3 in for x and take the antiderivative. But to find n prime of 3, we will have to find the derivative of this, which will require second theorem. So second theorem says the operations will cancel each other out, but I got to plug my upper bound into the variable, multiply it by the upper bound's derivative. So okay. Any questions with part H? All right, part J, go through the appropriate chain rule, find the derivative, and then evaluate the derivative at 5. Okay. K is also a chain rule, but the order is a little bit different here. So that my outside function is f. My inside portion is the net log of s.
Why do you not use chain rule to take the derivative of the inside as well?
We do. So the inside is the f of x. So f of x's derivative would just be f prime. So technically we are doing like f prime of x times 1. So there's a little bit of chain rule here, but I'm leaving that 1 out of it. So it's f, u, this is my u prime over u here. It's part of the, it's that f, think of that f of x as the u value, and we're just having to take care of that natural log's derivative. So we just follow the rule u prime over u, so f prime over f. Okay, I want us to work on some of these problems on page 22. Before we get there, though, let me just show you a variation of first theorem. This is on page 28. Has a bunch of formulas for your reference. So we know this one is true, right? If I take the antiderivative of f prime between a and b, the antiderivative is that process will rise up to f of b minus f of a. We can rearrange this in a way where if I'm looking for a final position, it'll be my initial plus displacement. So final position equals initial plus displacement. And this can be useful whenever there's no established formula for your integral. So an example of that would be page 22. Here, normally you'll see a problem that will just say, oh, f of x is just the integral from 0 to x of g prime of t dt, right? Here, if that's the case, we can just plug into the formula and just do whatever it spits out. But if they just give you an entry point, then we have to think of it as, okay, well, I can find displacement, but it's always going to be in relation to that location. So if I want to find any of these f of 4, f of 4, f of 6, f of 7, I want to kind of follow this formula here to help me kind of keep track of where I am in relation to my displacement. So if I want to find f of 4, I know I have to involve the displacement between 4 and 10, but I also have to make sure I include where I begin. So f of 4 is what I'm looking for. F of 10 is my starting point. And I got to be able to figure out how much has changed between 10 and 4 under my f prime. We can also go ahead and find all the area that we have to involve. So let me shade in all the parts that we're concerned with here. Now you may see other triangles, but again, we only care about the portion of the triangle that's between the graph and the x-axis. Okay, let's find all those regions. One half base times height. I'm always following what my formula says. I'm always starting at my initial, ending at my final. So because my definition shows the bounds out of place, I'm going to swap the bounds and pull a negative out front. So the integral from 4 to 10 will just be 4 minus 4 minus 4. So negative 4 total. F prime of 7 is just, this is my F prime graph. So F prime of 7 is just the order pair. Negative 2, point on the graph. Then F double prime of 7 is just the slope of my F prime graph. So slope, just pick 2 points, rise over run. My slope is going to be negative 4 over 2, which is negative 2. On what interval between negative 4 and 12 is the graph of f both increasing and concave up? So let's keep reminding ourselves, we're looking at the derivative graph. So anything above the x-axis is positive slope. Anything below is negative slope. On the x-axis, slope 0. So we can create a slope sine line. We can also create a concavity sine line, right? Peaks and valleys are your points of inflection, and the rise and fall represents positive rise and fall represents your concave up or concave down. So positive slope is concave up, negative slope is concave down. So if I line up both my sine lines, I can see where my graph is going to be experiencing increasing. So it needs to be above the x-axis and showing positive slope. So above the x-axis and showing positive slope, -2 to 0, and then from 2 to 4. Okay, part C, equation of tangent line. So find your order pair at the function level, find the derivative using product and chain. For the derivative, you can find your slope, and then finally end up with point slope form. Any questions with part C here? Okay, part D. Part D looks like a complicated limit problem, but it's going to eventually show itself in terms of L'Hopital's rule. So remember, with first thing we do with limit problems is we evaluate the limit, show what's going on, right? If we get a real number, then we can stop. But if we get 0 over 0, that gives us the green light to do L'Hopital's rule. Part B, first thing to do is plug in 2 into all the x's. It's going to end up cleaning up nicely, just 0 over 0. And because you get 0 over 0, you get that option to do L'Hopital's rule. So we know e to the u's derivative is e to the u times u prime minus 1 to the minus 1 over e to the 5th. That's just the constant. It goes to 0. G of 2x becomes g prime of 2x times 2. 4 goes to 0. Replace all the x's with 2. Use your table of values. And should you get it down to a numeric limit. Okay, so we're going to stop at page 22, but in 5 minutes, if I can just come around and just take you guys off for classwork. So page 19, 20, and 22. We worked through those problems, those pages together. Just want to kind of give you, just want to not have any homework over the break.
I need to stop wearing white clothes. I can't wearing a white.
Everyone is-
I have white shorts on. I think I'm good. I just need. I'm gonna have like pink clothes when I walk. Yes, but that's not really the point.
I remember this.
Well, I was taking my clothes. I was making up my clothes. No, so I think I got some.